Okay, no zombies in this one. Transition elements have delocalized d-electrons. Okay, so explain the high melting point and electrical conductivity. Well, to cut to the chase, essentially period 4 d-block metals have delocalized electrons in that 4s and the 3d sublevels. Delocalized means the electrons have left the atom and can now move around in that metallic lattice freely. So these produce strong metallic bonds since they leave behind, well, relatively highly charged ions and create many of these delocalized electrons in the C. So now there's a lot of electrostatic attraction, a lot of negative electrons in the C, a lot of relatively highly positively charged metallic ions, strong bonds, and that gives you the high melting point. I made a little graph here. Yep, so the transition metals are there. And of course, the IB doesn't really think that scandium and zinc are transition metals because of the full D block when they're ions or the empty D block. Anyway, so in terms of electrical conductivity, because there's lots of these delocalized electrons, that means that they're very highly electrically conductive. If there's lots of electrons only loosely bound, they can pass through the metal easily. Now, just a small side note here, the reality is a lot more complicated than this, not because I'm so smart and I don't want to tell you, but just doing a bit of research. But this seems to be what the IB wants you to know. Alrighty, and then another little thing. So why is that trend of melting points all over the shop then? Why isn't it a nice, straightforward trend, like going down group 1, the melting points decrease? Well, that's because there's a whole bunch of variables when it comes to metallic bonds. The S and the D field, my God, variable oxidation states. Is it copper 1 plus or 2 plus? The lattices have different shapes, face center cubic, body center cubic. They're different sizes, they're different. Oh, it's just a lot going on. But essentially, if you've got lots of delocalized d electrons, then you're going to have stronger metallic bonds, such as chromium, which is going to give you higher melting points. And if there's not many d electrons involved, like scandium, you're going to have lower melting points. I'm not fantastically happy with this video, but looking at the textbooks and using my brain, I'm pretty sure this is the least you need to know to get a 7. And we're done.